Yes, we will proceed. We'll start.
Roll number 11. Roll number 11.
Who has to introduce roll number 11, I hope.
Roll number 11. Roll number 11.
रोल नंबर 5.
जयदीप.
Hello.
Are you present, sir?
येतोय का
Who
आवाज?
is going to introduce?
हा सर, आवाज येतोय ना?
येतोय सर, बोला सर.
Dr. Baban Ingole is distinguished former chief scientist and head of the biology division at CSIR National Institute of Oceanography in Goa. He also served as a visiting scientist at the National Center for Polar and Ocean Research in Vasco, Goa, and senior scientist at the Center for Marine Living Resources and Ecology, Cochin. Dr. Ingole possesses over 45 years of experience in the research, teaching, management, and mentoring at the master's and PhD levels. His expertise includes marine ecology, biodiversity, Antarctic biology, environmental impact assessment, coral reef ecology, and climate change. At CSIR NIO, Dr. Ingole has completed over 200 research projects, including 45 major ones. He is recognized PhD guide in 5 Indian universities and his supervised 14 PhD and 90 MSc dissertation. Notable, Dr. Ingole has contributed to 3 Indian Antarctic expeditions as well as discovery expeditions. His research on the ecology and Antarctic freshwater lakes and deep sea biodiversity is widely acknowledged and referenced. At NCPOR, Dr. Ingole conducted baseline environmental and benthic ecological assessment for deep sea meaning in the Indian Ocean. His contribution has been casting for new biodiversity, discovers for deep submitted sea mountains, ranges, and the Baisal Basin. His study and exploration has resulted in the description for several new benthic species and new species distribution records for the Central Indian Regis system, as well as improved research effort for deeper biodiversity of Indian Ocean. Dr. Ingole has been the recipient and several prestigious awards, including the Professor N.R. Menon Memorial Award, the Young Scientist Award in Biosciences, the Japan government. SCOR Visiting Fellowship, BB Tarapurwale Fellowship and Darpan Puraskar. Furthermore, Dr. Ingole actively contributes to various government expert committees such as the Maharashtra Coastal Zone Management Authority, Goa State Wetland Authority, Goa State Biodiversity Board, and the Wildlife Board of Goa. Dr. Ingole published 250 research papers within the citation of 5,700. Thank you, sir. Hello.
Yes, sir. Thank you very much.
थँक्यू सर. इंगोळे सर, आपण काय करूया, पार्टिसिपेंट काय करतात, मध्येच अनम्यूट करतात, तर सगळ्यांना म्यूट ठेवावं लागतंय. मी जेव्हा आपल्याला नंतर 10-15 मिनिटं राहील मग तेव्हा आपण त्यांना अनम्यूट करू शकतो सर. त्यामध्ये डिस्टर्ब खूप होतं सर.
Hello. Jawan sir,
Yes, sir. Yes, sir.
I'm supposed to start or anything else is there?
Yes, sir. Yes, sir. You can start. But one thing, all the participants are now on mute mode, so that they will not disturb you.
Okay.
They will unmute at the last
Yeah,
half an hour.
during the break time or the last, yeah.
Last half an hour.
Yes, yes. Understand.
Okay. Welcome,
What
sir.
time, what time we should have a break, tea break?
At 4:30, sir. 4:30.
Okay.
Around 4:30. Around 4:30.
Okay, sir.
I would like to add some more things, dear participants. Dr. Ingole has worked as a eminent scientist in National Institute of Oceanography, and the proud thing for us is that he is a son of soil. He is belonging to Marathwada, particularly Ingole, and he is alumni of our university. So once again, I welcome you, sir. Please go ahead.
Thank you, Jawan sir and Solunke sir for that introduction. I will try to present today some of the research work which I have done and also the review of the work in the field of disaster, specifically with respect to the oceanic disaster. One is about the cyclone and second is about the tsunami. And I will be talking largely about the impact of tropical cyclones on the coastal, tropical cyclones and the tsunami on the coastal ecosystems. Okay, let me try and make the presentation visible to you. Is it visible? Hello, is it visible to everybody?
Please. Yes, sir. Yes.
Yes, sir. Yes.
Okay. So as I was telling, I am going to talk to you about two aspects, both related to coastal disasters, and one is about the cyclones, and another most important is the tsunami. So here is the first one. It will be combined one, and let us see how we'll fold it, because both are having significant impact as and when they occur on the coastal ecology, coastal livelihood, and coastal environment as such. One is the tsunami. I have titled it Journey to the Heart of Tsunami because I was part of one of the international expedition which explored the 2004 tsunami. What are the causes of 2004 tsunami? And hence, I thought I will talk more about the tsunami initially. Of course, it will be mix of both as and when there is a common things are there. So we all know in December 2004 there was in 24 December night, so or early 25th of Christmas night, 2004, there was a disaster happened in the Indian Ocean and particularly near the Andaman Islands, which has caused severe damage in the Indian Ocean region as such, including India and other countries, but maximum damage was done in the Thailand and Indonesia, and then also towards the Indian coast. So whatever the damage it caused, we all are aware about that, and I thought I will explain a little bit about the causes, how does it occur, and what are the factor contributed for this tsunami was a very huge organ earthquake, which was measured at a Richter scale of 9.3. Yeah. And what happens actually, because of absence of any tsunami warning system during that time in the Indian Ocean region, the human as well as the environmental damage was multifold. Huge damage it occurred basically because there was no tsunami warning system. In fact, the earlier predictions were there, this region may not have the tsunami. Like that, people, because for hundreds of years, there was no tsunami occurrence reported in the region. And that is why people were not even expecting it. Globally also, there are other regions where they expect, which are, prone to the tsunamis. But this region was not at all known. And that is why not much preparations was done, or even the system was not available to warn them or give them the advance information. And therefore, there was no chance to forecast it in advance, either on the basis of the earthquake or, the post effect of the earthquake. And that is how the tsunami caused huge damage in the 2004 tsunami caused huge damage in the Indian, particularly in the Andaman, Bay of Bengal and surrounding areas, down towards up to even it reached to the South Africa and towards the Australia. Well, what is the tsunami waves actually? Tsunami waves, how does it occurs? As if you can see it, just for the definition purpose, this is there. Tsunamis are often no longer taller than normal wind waves. What waves we get it on the coast when there is a high tide, or there is a during the neap tide, during full moon, new moon, there is a tide, which is high tide, what we say. Usually tsunamis are of that height. However, it comes with a very high speed. And that is why they cause much more danger to the coast or wherever they occur. Wind wave comes and go without much flooding. Whenever there is a wind waves, they come and go back. The regular frequency will be there. So they won't have much flooding. Whereas the tsunami waves, it comes with so fast and it brings so much water that it gets flooded into the land world. And the speed of that waves is so that it not only get flooded, but it get retrieved. So it goes back with a similar speed and take it with that water body and that wave, whatever is there. So that is the effect of the tsunami. So what happens is actually the wavelength of typically of such speed is like 10 to 100 kilometer, and it lasts something like 10 minutes to 1 hour. So during that duration, when it lasts or it is residing on the coast, it causes the disaster. Like in any shallow water wave, tsunami propagate at very fast. Whereas the shallow water waves, it won't propagate that fast. And it propagate and then travel at very high speed, like sometimes up to 500 to 700 kilometers per hour in the open ocean. And when they are traveling in the open ocean, what happened? It will, because of the water depth, the energy is distributed as it comes to the coastal area where depth is shallower, as it becomes shallower and shallower, then the energy get intensified. And that is how it will come so fast with the high waves on the coast. Secondly, the current associated with such tsunami waves are usually small. However, unidirection it will be there. And therefore, once it comes, it goes with a similar speed back to the sea. It certainly caused a lot of damage. There's a perturbation to the, the area wherever the it gets, the landfall. So that is what the impact it causes. Well, how does it occurs actually? If you see it in this particular slide, you have the land side, both the side, this green is the land side, and this is the sea is here. You can see the sea block is blue color is the water, and below the water, there is a yellowish color. Now this is the earth. So this is the bottom of the sea. This is the bottom of the sea. Above that you have the water. You can see this is the above that is the water is there. This is the water. This is the land both the side, and you have the sea. So inside the sea, the water is now depth is there, and below that here what you have got it is the bottom of the sea, and bottom of the sea where you have got it after the water level goes here is the hard bottom. This is the earth. This will be solid. Sometimes sedimentary, sometimes very hard rock will be there. The depth of this particular varies, depending upon the oceanic depth. For example, 2004 tsunami time, the depth of this area of Sumatra was around 2 kilometers, 1.7 kilometer, roughly 2 kilometers. Now there are two plates. You can see it here. Here is one plate and here is one plate. Above that is water. All this thing is there. So these two plates are collided here. These two plates. So in our case, I will show you in the other slide. In our case, this was the Indian plate and this was the Asian plate. So these Indian plates collided with the Asian plate, and then this collision occurs there, and therefore with that there was an earthquake. So here was an earthquake where there are two plates are meeting, and because there was earthquake, there was so much impact of that earthquake that it pushed the 2 kilometer water on the top. So this plate was above the Indian plate. This Asian plate was above the Indian plate. So it has pushed, the impact has pushed in such a way that water above this thing like 2 kilometer and huge Bay of Bengal, full water was pushed above, and it was pushed around 60 feet above with very high speed. I will tell you that also we calculated a little bit. And then what happened, you can see. This is how the tsunami occurred. Here, we'll see it again. See, here it is. How it got distributed, how the waves, it occurred. It occurred basically somewhere here, near the of Sumatra. You have the Andaman Island. This is Indonesia, their island, and there is one small island, Indonesian island, within the EEZ of Indonesia, very close to our EEZ, and it occurs there. So, anyway, this is how, again, we can see it. And if you can see it, this is where we have these are the areas where it got ruptured and tsunami occurred, and these tsunami waves, the intensity was so high. So impact was very high nearby area, both, to east side and west side. West side is Indian and east side is Indonesia, Malaysia, Thailand, all those small island countries where, are this side. So there was a huge impact on both the side of this one, and it reaches, you can see it in fact reached the South Africa. Here it is reached to Australia. So the propagation of the waves was such that it took roughly 5 hours from here, this wave, it took 5 hours to reach to Australia. 7 hours from here, within the 7 hours, it reached, in fact, the Arabian Peninsula. Indian coast, it was only 2 hours or something like that, within 2 hours. And did reach South Africa. That is where here, South Africa, down portion of South Africa. It reached South Africa roughly around 10 to 11 hours. And that is how the tsunami of 2004 earthquake of Sumatra was triggered. Well, this is the tsunami what I was talking about. Now we will see about the cyclones. Cyclones are basically, the coastal high concentrated where the depression takes place. This causes with different reasons. One of the reasons is the variation in the temperature, sea surface temperature. Generated very high wind speed, and then it is so much it get converted into the storm. This result into the powerful surge of the water being driven or is towards the coast, because it has to come and fall on the coast, then only it will be reduced, the speed will reduce. So impact of such storm surge can be various types. Immediately when it gets to the beach will get eroded. Coastal habitat, whatever the habitat is there in that area, whether a forest is there, a mangrove is there, or there are villages are there, houses, everything get damaged because there is nothing can defend it when it comes into that impact. Depending upon, of course, what type of wind speed is there, it also generates rainfall and also sometimes very high waves. So because of that high waves, it get in the land or on the land and it get inundated. So flooding takes place. It also because of the flooding, seawater, it comes and it get contaminate the seawater with the fresh water, and farmlands will get destroyed immediately because all salt will come into the freshwater areas, and also the farm will get covered with the salt. So sometimes it forms a big seawater get accumulated and forms saline lakes into that area because it get accumulated wherever there are depressions are there. So what is the important is the increase sea surface temperature is increasing. It is already evident that sea surface temperature in the Indian Ocean particularly is increasing every year, and the frequency of increase of this cyclone is also increasing very much. Regions where there is a evident of the climate change is there, that shows that the impact of climate change, particularly increased sea surface temperature, is very much visible in the both Bay of Bengal and Arabian Sea. Specifically, it is very much visible into the Arabian Sea because Arabian Sea was not known to be prone to such cyclones as it was Bay of Bengal. Bay of Bengal was known that every year there will be few cyclones, but Arabian Sea was not known. However, in recent time, the cyclones are also frequently, occurring in the Arabian Sea also. And damage caused that due to these cyclones, we know tropical cyclones. And you can see the frequency of these cyclones or hurricanes, what they say in Western area, they don't call cyclones much, they call hurricanes. So you can see, for last 1 century, the occurrence of cyclones annually, bigger cyclones, these are major cyclones. And you can see as proceeds, there is a frequency of occurrence is, small tropical storms and big hurricanes. So red are all big cyclones. These big red are all, blue are the storms, tropical storms, small cyclones, all these things. But then the bigger the hurricanes, which are, major cyclones or mega cyclones, what we call as, these are the red one, which is, and you can see the frequency is increased, the number is increased towards the recent time, is very much it is there. And once it is, reach, the economic loss of these cyclones is huge. In fact, some of the economists have calculated that these losses because of these cyclones are going to be double by the end of this century. Although this is globally, they are talking about it, there are not much estimates towards the tropical cyclone, where we are there, tropical cyclone. But we know that every year in India, there is a large damage occurs on the coast of Andhra Pradesh, Tamil Nadu, Orissa, West Bengal, and we know that Bangladesh is one of the area because landfall usually occurs in West Bengal, Orissa, and north of that is the Bangladesh. So therefore, that is the area which is prone to be, damage or landfall of the cyclone, because you can see that what happens when the cyclone comes. Once it occurs on the landfall, it will die down, but the impact is so that when it comes on the coast here, it will damage all the whatever the structures are there, the electric pole, your trees, your buildings, everything, it will be damaging. And that's what it happens because it impact on the cyclonic landfall point is very high. Well, you can see it is not only the Indian Ocean region, but the Caribbean region, Pacific, some of the areas. Also, the intensity of cyclones and floods and, is very high even in the Caribbean region. So these are the storms. So these are the cyclones. You can see that, and as we come in 2000, this is for 1960. So 1960s to the 2010 is shown it here. And then you can see that how the intensity is been on increase even in other areas also. And what happens? It is not only the occurrence of the cyclone, but also the impact of these cyclones. How does it occur? Now, if you see it that these are the cyclones as we were just counting, and in the subsequent years, how they are increasing. If you look at it, the landfall, the percentage of the landfall means cyclone, sometimes it is small when it will die down in the sea only. So there will be not much impact if it die down into the sea. There will be some, of course, damage with the environment like fisheries or churning of the sea, but those are naturally occurring things. But if it occurs on the land, whatever is structure is there, ecology is there, living human beings are there, villages, everything get damaged. So if you look at it 1980 and 2020, and if you look at the landfalls, if there are 10 cyclones, how many landfalls? And these are the number of cyclones, landfalls. Severity of, these are tropical cyclones, particularly the cyclones in our regions. And you can see the intensity from 80s to 2020, out of 20 cyclones, almost 15 are having the landfall on the land. And therefore, it will end up into major disaster. That is how, if you calculate the ratio in terms of percentage, so here it is like almost 40 to 50%, reaching 50%. In recent time, almost out of every 10, 5 cyclones are causing damage because the landfall point is not in the sea, but it is on the land. And that is how the intensity of these cyclones is increased, occurrence is increased, and also the landfall. Landfall means it is coming and ending up on the land. So it will cause damage. There will be heavy rain, there will be flooding. This is what is the aftermath effect of the cyclone. You can see how the frequency of cyclones on the landfall. Here it is shown. As I was just telling you, there are 4 cyclones occurring in 1 year. Major cyclones. These are major cyclones. Like what we have witnessed in 1998, there was a major cyclone occurred in Orissa. So everybody knows about the Orissa cyclone. And that is a major cyclone. So that type of cyclones, if there are 4 cyclones occurring per year, 2 of them, you can see that, 2 of them will have the landfall. So there is 50% the frequency of it is there that it will end up on the land, and therefore we need to have structures. We need to have cyclone warning system, pre-warning system, as well as mitigating. We have to prepare. Earlier it was not there, but now we have got such a system available in India, and Government of India have put up huge expenditure towards cyclone mitigating measures. Disaster management separate department is there. Government of India's one of the cabinet minister or some senior minister is heading that one every time. Okay, so if you look at it, the tropical cyclones, how they are intensifying, and this was Ministry of Earth Sciences, Government of India have shown it in severity of cyclones or increased cyclone in India. You can see that both Arabian Sea and here is Bay of Bengal, and India is somewhere here, and this is the cyclone which is ending mostly on the land, either east coast or on the west coast. They are, but largely on the east coast. And from 2010 to 2019, 10 years, last 10 years, the frequency is so high. So the spikes in sea surface, the scientists have particularly predicted that if there is a sea surface temperature increase, and if there is a significant increase, there are possibilities of cyclone also will be increased, or possibility that this year, if there is an increase in sea surface temperature is more than the previous year, the possibility of increasing intensity or number of cyclone as well as its intensity also is going to be high, and that is what some studies have shown it. Now, what happens if these cyclones are occurring on the coast? So what impact it will cause? Because the coastal ecosystems, we have coastal beaches are there, we have coral reefs are there on the coast. There is huge fishery occurs along the coast, both east and west coast of India. There's agriculture going on in huge. In fact, one of the rice bowl of India, which is called as Andhra Pradesh. And Andhra Pradesh, one of the area where is now the new capital of Andhra Pradesh, Amravati, what they say it, and it is Rajamundry, Kakinada, and Rajamundry, Kakinada, Amravati. That is the region of Andhra Pradesh where every year huge cyclones, but it also is a major portion of rice production, and they supply rice to the rest of the India. Huge rice production takes place in that area, and they supply it, and every year that get damaged. So coastal ecosystem, which provide large number of services, as I told you, agriculture is there, fishery is there, mangrove systems are there, forests are there in such areas. They provide, they usually protect the land from erosion. What are the forest area is there, or beaches are there, or sandy vegetations are there, and they also provide clean water. These coastal areas. Also, because of the greenery available in such areas, coastal vegetation take parts into the large amount of carbon sequestration. So, these coastal areas are very important from the ecological ecosystem services providing. Sometimes there are a huge salt marsh are there, mangrove forest are there. There are the oyster reefs, because the fishery, very important oyster reefs are there. Estuarine areas are rich in the molluscan fishery. So oyster is one of that. The clam fishery is there, oyster fishery is there. Seagrass meadows again support the nurseries for some of the marine fishes, and also some of the wildlife. It is very important area, seagrass meadows, then salt marsh, mangrove forest, and most important is the coral reef. We have major coral reef both on east and west coast. East coast, Andamans are there. West coast, we have Lakshadweeps and all these islands. In addition to this coastal area where Gulf of Kutch is there on the west coast, Gulf of Mannar is on the east coast. So these are area very rich in the coral reef. Also, there are the mangrove ecosystem. All the coastal states, particularly Gujarat, Andhra Pradesh, Maharashtra, Karnataka, then West Bengal, Orissa. These are some of the states. Huge mangroves are there. Sundarban is world's one of the largest, forest, mangrove forest reserve is also in West Bengal or in India. And these mangrove systems are very important from different type of ecosystem services they provide to the human being in that area, and naturally also occurring because carbon sequestration takes place basically in a huge carbon sequestration in the coastal area. Mangroves are taking a major chunk of that carbon sequestration. Of course, salt marsh, also other seaweeds are also there in the along the coastal area wherever you have sandy bottoms or lagoons area, and where you are rocky, there are the seaweeds are there. But largely it is the seaweed, seagrass meadows and mangrove system, the major what carbon sequestration takes place in the coastal area. So what happens with the increase cyclonic storms, as you can see, this is with respect to the Indian coast. If you can see it, 1970 to 2020, and this is how increase cyclonic storms. I have already shown you in the previous slides. There is a intensity as well as the major cyclone landfall is increased, and that increase is also seen it. The impact of such this is also seen it here since 1970 to 2020. The damage to the different ecosystem on the coastal area, major like oyster beds. These are the oyster bed yellow, then seagrass meadows. Then you have mangrove system, this blue mangrove system, and this dark blue is the coral reef. So coral reefs are the one which are getting damaged largely with this type of cyclonic this thing, because they are shallow water ecosystems and they get exposed immediately. They are very sensitive for any changes. Coral reef usually, because they usually survive in very clean waters, unpolluted waters, and wherever there is change occurs in such type of either temperature or in the cyclone or this thing pollution, corals are the one which will take the major which will have the major impact of this thing, because they are sessile, they are attached to the rocky habitat. They can't have any escape either from pollution, either from increased temperature or any cyclone. So whatever happens, they will have to either bear it or they will have to perish from that. That is how the coral reefs are one which get damaged immediately with such type of cyclonic and then it will get degraded in the due course of time, and then the services what they are providing to that area will be also hampered. We will not have those services. What coral reefs, for example, are considered as the nursery grounds for the marine fishes. They are the hatcheries and nursery grounds. Majority of the fish which is in the sea, they breed and nurture their larvae into the coral reef wherever it is there. Because there is a protection, there is high food availability, and larvae can get hide into the coral reef, coral meadows. So therefore, coral reefs are very important. Also the mangroves, for example, are very important nurseries for the estuarine fisheries, both prawn and fishing or majority of commercially important prawns, they breed into the mangroves. the mangrove creeks. And because there is a huge amount of food available there, carbon content is very high. Organic carbon content is very high in the mangrove system. Therefore, the productivity is very high, and majority of the brackish water fishes which can tolerate seawater and mix fresh water, they come to the estuary for breeding purpose, and then they complete the nursery larval growth, and then they will return to the open sea. So that is, if it is getting damaged with these cyclones, the fishery that area and that particular year, fishery will be completely damaged. There won't be a good fishery, particularly if corals and mangroves in that area if get damaged. The services provided by this system to the natural services will also get hampered, and that therefore the fishery, as I can tell you, will be not very good, particularly that year if it get landfall in that area. If landfall occurs into the mangrove rich area or it occurs in the coral reef area, then it is going to be damaged. There are some oyster reefs. Example of oyster reef I can give you is, for example, there are good oysters into the Kakinada Bay. Kakinada Bay is known for it. There are some areas in Maharashtra, if there are people from Ratnagiri, then Ratnagiri, where you have got the Shirgaon Creek. Shirgaon Creek is very famous for the oysters beds. A very good oyster, we get it in Shirgaon Creek in Ratnagiri and some other areas also. But Ratnagiri, I have seen it, I have done the work there. That is why I am telling. Then we have, in Maharashtra, we have very good coral reefs in the Malvan. It is just, you can walking distance from the beach. When there is a lowest low tide during the full moon or new moon, you can, in fact, low tide area, you can walk to the Sindhudurga fort, and coral reefs are around the Sindhudurga fort. So those areas, if there are any sort of pollution or any cyclone, it occurs. Also in Sindhudurga, particularly in Malvan, Taluka, both Malvan, your Jaigarh, then Devgarh area, these are some of the, and up to Ratnagiri, they are very rich in the mangroves also. So mangroves as well as coral reef areas are very rich into the Ratnagiri to Malvan area. There are the coral patches. Most of the coral reefs are occurring in Malvan around, but mangroves are spread throughout the Maharashtra coast, from Malvan to the Mumbai. And therefore, which is very important, if there is a cyclone occurs in north side also, Gujarat, you have got coral reefs in Gulf of Kutch, and mangroves are there. Till the north, border, we have mangroves are there in the Gujarat coastal. In fact, in India, the maximum mangrove area spread is in Gujarat. Yeah. So this is what is happening in last couple of years about the cyclones and its impact. Now I'm coming to the tsunami, back to the tsunami again. As you can see it in this slide, because this is the work which I have been doing it last couple of years at National Institute of Oceanography. So I thought I will, talk a little bit more about the process of earthquake and the effect of such earthquake, if it is a large earthquake, how it can be converted into the tsunamis. Well, if you look at it, this slide, you have the entire world map is there. You have India is here, Africa is here, you have Japan is here, this is Australia, these are Indonesia, Malaysia, and those areas. America is North America, South America is here, and then Europe, entire Europe, Russia, China is here. So, if you look at it, this red line, it is passing from the North Pole. This is your Siberia is there. So it is, red line is passing through the down. So here is the North Pole, here is the South Pole. Okay, down Antarctica. The South Pole is here, and here is the North Pole. So this red line is passing through the South Pole to North Pole, and as we know, Earth is round, so it goes back again and it meets here. So what is this red line? If you look at it, this is the Atlantic Ocean. Here you have the Pacific Ocean. This side, the Pacific Ocean. This is the south. We have the Antarctic Ocean, and this is the Indian Ocean. Okay, these are the major oceans what we have got: Atlantic, Arctic, Pacific, Indian Ocean, and Southern Ocean. Down what we have got is the Southern Ocean. Now, this red line is dividing the plates. I was telling you a little bit about the plates. Now, if you look at it, this here is the name is given Southeast Indian Ridge. Okay, this is Southwest Indian Ridge. This is Southeast Indian Ridge. And they are meeting it here. It is called Triple Junction is here. And then from here, you have the ridge called Central Indian Ridge. So this is the Central Indian Ridge. Okay, for us, these are three are most important. That is why I have put it into the separately or highlighted it. Southwest Indian Ridge, Southeast Indian Ridge, and Central Indian Ridge. What is this ridge? Ridges are nothing but the dividing the plates. It occurred during the plate tectonic. Now, this African plate, this is the Indian plate, and this here is the Asian plate. I was just telling you. So this is like Australia. So this is Asian plate is there. So this Indian plate got divided, is separated, and this is separated. This line, red line is the boundary line, separate line. But we have the sea here. Almost 3 to 5 kilometer depth of sea is there. So water is 3 to 5 kilometer depth of water is there. Below that is the sediment or seabed, and below that almost 15 to 30 kilometer below is the core, earth core, and in that core, this red line, what you are saying it, this red line is flowing with lava. So lava is flowing. This red line is nothing but it is a lava, and it is flowing circumpolar. So it goes and come back like this. But because it is a liquid and very high temperature lava, almost like 1000 to 3000 degrees Celsius lava is flowing, but it is in the core, so very deep, 15, 20, 30 kilometer in the earth core. On top, we have got the seawater, almost like 4 to 5 kilometer of seawater is there. So when this lava is flowing continuously, these plates are also moving. These plates are moving, and usually they are moving in this Indian Ocean region. This Indian plate is moving towards the northeast. And that is why it is pushing the Asian plate where Himalaya is there. So this is the Himalaya. So here the another plate comes here. You know, from here ridge is there, but that is where the Andaman ridges formation is there. So this plate is divided, Indian plate and Asian plate is divided here. So this is pushing it down, and Asian plate is up. And that is why the Himalaya is growing every year. So these mountain chains, is all around. So mid-ocean ridge is the most extensive mountain chain. This is actually mountain chain, but sea mount. This is below the water. There is a range of mountain change. This is a mountain range is there, but it is the below, and it is nearly 65,000 kilometers across the earth. Across the earth it is there, but it is very important because it is flowing the lava and maintaining the earth's momentum. Now, what happens? Because these plates are moving always, there are always collision. This plate will collide with this one. Now, once it is collide, they were once upon a time one, but when the plate tectonic occurred, it has been separated, and now it is separate. Completely, there is a valley, huge valley, kilometers of depth valleys are there below it, and below that is the lava flowing. Now, this valley is nothing but there are the cracks. So this throughout there is a crack on this. And as I was telling, In one of the earlier slide, I can go back and just show it to you so that you'll come to know what I want to say it. Okay, this is how, what I was telling you, here is the core of the earth below. The water is here and here is. So this water, you can see that this water from top, wherever there is a crack, the crack is here. One plate is here, one plate is here, and crack is here. So water is flowing through this crack. This is a cold water, sea water. It flows through the crack and then it goes down to the, where it goes, I'll show you. Because there is a seepage. So that water goes down here and it meets to the lava. Now lava is already flowing with 1,000 to 3,000 temperature high. So once the seawater on top, it get percolate, seepage, percolate and meet the lava, that will evaporate further. It will evaporate further and there will be pressure develop. The huge pressure will be developed. Now, once that pressure is developed, that pressure needs to be get out because it is a huge pressure it is developed. What happens in the process is, now, as I was telling you, this is that red line is there. Okay, everywhere is there. Now here it is shown it very clearly. This is the Indian plate. Okay, now you can see this is Arabian plate. Separated. That is why we get earthquake here in Balochistan, Iran border very regularly. Then here is we have the Indian plate meeting the Asian plate. So Himalaya is here. So this plate is pushing here and that is why Himalaya is growing every year. Now this plate, Asian plate, this is the crack coming down and this is the most important because Andaman is here and that tsunami occurred along this line. Okay, then you have got, this is, I was talking about, this is a major Indian Ocean, Central Indian Ridge. This is Southwest Indian Ridge and Southeast Indian Ridge. This is a triple junction. We are National Institute of Oceanography and National Center for Polar Ocean Research. Both the institute, one is CSR, one is Ministry of Earth Sciences. We are working in this particular area now for what I'm telling you. So here is that. This plate is, these are the plate, this is the water, blue is the water, and this is a crack. As you can see that one plate is going below the other plate. As you can see that this is one plate, for example, this is the Indian plate and this is the Asian plate. So this Indian plate is going down and pushing this. This Asian plate is pushing towards the north. It's going down and pushing it. Okay, so that is why the Himalaya is growing every year. Sometimes it is pushing either side. So here is a force is there. This is the crack is there and this is either side. So there is a separate valley is created. Sometimes this is both are combining together. If they are combining together, then there is a problem like this. One goes down and one comes up and therefore there will be huge water movement takes place here. And if this happens, and if there is an earthquake, then this will be pushed up and that may trigger the tsunami. This is what happens. Actually, practically, this is what happened during the 2004 tsunami. In this area, it occurred. Now, if you see, this is the map which was earlier, before the plate tectonic, major plate tectonic plates. As you can see, you have Africa is given it here, South America is here, you have Antarctica, this is India, this is Australia. And if you look at it, this map particularly, what you need to do is you have to move this map anti-clockwise, not clockwise. If you move it anti-clockwise, today whatever you are seeing it here, it will be there. What happened? Okay, so this is what, if you can see about the different trenches and ridges are shown it here. This is the map of seabed. Without, suppose the water, how seabed looks. Here is, you have got the, Central Indian Ridge, Southwest Indian Ridge, Southeast Indian Ridge, and there is another ridge I was telling you, which is coming from Himalaya, going down is here, and here is it is meeting. It is called 90° east. It is going down to towards Australia. This is also very important. 90° east ridge is there. In our region, what is happening is this. You can see it. You have, this is the Asian plate and this is Indian plate. So Indian plate is coming from down and it is pushing it up. If there is an earthquake, this is what? Then there is a subduction. Subduction is what? One plate will go down the below and then there is an earthquake if it occurs because of that movement of tectonic. This will push, this will go down and push this up. Once this pushing it up, whatever is water is here. You can see whatever water is there, that water will be pushed up. And that depend on what type of explosion takes place here. This explosion, what is the intensity of that explosion? This is how inner core is there. You can see earth. This is the blue water. This is the earth surface below the water. This is how it is there. These are the cracks, what you can see. In between there are the cracks are coming, and through this crack, seawater, which is cold in this one, this cold water will percolate through these trenches. There are trenches. Okay, so this will percolate down and it goes and meet to the core. Now core is the inner core, outer core, and here is lava is flowing. So once this water comes in contact with core, it will be hot and it will increase the temperature and also the pressure, because it get converted, water will boil it and get converted into the vapor. Once it get converted into the vapor, these vapors are going to come out because the pressure is generated there below in the core. Once that pressure is generated, it has to come out. Where it will come out, you can see it. I'll give you an example. This core is like a balloon. We are just blowing the balloon. मराठीत सांगतो, फुगा आहे आपल्याकडे, लहान मुलं जसं फुगा फुगवतात. जर प्रेशर जनरेट झालं की हा फुगा जो आहे तो वाढत जातो, कारण प्रेशर जनरेट झालेलं. So if you are blowing that balloon, a time will come that balloon is going to get burst. Now फुगा तो फुटणार, पण फुटतो कुठं फुगा माहितीये? ज्या जागेवर सगळ्यात वीक सरफेस असतो, रबरी सरफेस ज्यावर सगळ्यात वीक असतो, आपल्याला माहित होणार नाही, आपण फुगत जातो आणि ज्या जागेवर वीक सरफेस असतो तिथे तो फुगा फुटतो. आता या एरियामध्ये सगळ्यात वीक सरफेस कुठे आहे? जिथे ट्रेंचेस आहेत किंवा जिथे रिजेस आहेत, कारण ऑलरेडी दोन प्लेट सेपरेट झालेले आहेत. दोन प्लेट सेपरेट झाले आहेत म्हणून ती रिज आहे, आपल्याला माउंटन रिज आहे किंवा ट्रेंच आहे, दॅट ट्रेंच आहे. सो that balloon will get burst, means the pressure will get released in the place where ridges are there. And this is where the ridge, you can see it, what happens during the tsunami. So this is our ridge is there, and these are cracks are there in this one. So this star, particularly this is the star, main event जो झालेला आहे. So this is what main event, more than 9.3 Richter scale चा जो blast zala, earthquake zala. So that earthquake occurred here. This is the place. This is the place where it occurred. And intensity of it was so high because the magnitude of that earthquake was 9.1 to 9.3. Finally, they arrived it and they were saying that it is the 9.3 Richter scale. But there was not one earthquake. There were many earthquakes subsequent and previous also to that one. So that was the biggest earthquake in the earth history. That was second largest earthquake which happened of the Sumatra, that is which happened here in 2004. This is the place where it occurred. Okay, that depth of that earthquake I was telling you, Water depth was 1.7 kilometer, roughly 2 kilometer, but below that, you have the earth, you have the hard rock, and that depth where it generated that pressure, balloon, we generated, it was below that 30 kilometer. So you can imagine 2 kilometer water below that earth, and in that 30 kilometer below, the pressure was generated. The depth was, as I was telling you, roughly around 1.7, 1.3 kilometer. And the main earthquake which occurred, it also followed the subsequent aftershock. There are more than 500 aftershocks were there, and that has generated the tsunami. This is how it generated in 2004, December night, 24 December night of Sumatra earthquake occurred, and which was, you can see the water and the time. Here is time in minutes. How it is, how much time it is coming to reach Indian coast? 90 minutes. Roughly, they reached to 90 minutes. Whereas Sumatra, it was roughly less than that. As you can see it, we'll go back and again we'll see. See, it is within half an hour. It went to the Indonesia, Malaysia, Thailand, and that is the area where maximum damage was occurred during that time. Of course, entire east coast of India was also damaged. Sri Lanka, major damage occurred because the island country it is there, but it also have impact in the down towards the Africa also. Not much because the intensity was lower down that one. So it was the longest duration of fault, almost like faulting was around 8 to 10 minutes. So that shaking of the earth was around 8 to 10 minutes. It resulted in the water wave up to 30 meters. You can say 100 feet tall water wave was generated. And that is why that 100 feet water was moving at the speed of 500 to 1000 kilometers per hour. So this movement of this water was, you can see, 100 feet tall and moving at 500 to 1000 kilometers per hour. So when it comes with that speed and height to the land, it will definitely, take away whatever it comes into their way. And that is how what it has done. We have seen it. The problem was there earlier during that time in this area, nothing was known to the people. Okay. Because people were not aware about the impact of it. And also there was no system available for warning the people in the region, entire region. The death was so much. Roughly, it was roughly 3 lakh people in 14 different countries were killed within few hours. So 14 countries were largely affected because of this tsunami, which was very tall tsunami, and that is why it was called a unstoppable wave. Well, this is how the usually tsunami or storm waves are generated. What happens is, as you can see it, a schematic is given it here. So you have, this is the depth and this is the shallow coast is there. From here you have the vegetation, the coast is there. So if it generates here, there is a huge water is there. So energy is dispersed here and this energy is distributed in the water column. But as it comes towards the coast, the depth is decreasing. And the depth is decreasing, so energy get intensified like this. You can see this energy is getting intensified as we are coming towards the coast. So height of the wave, because there is no place for water to disperse, so it increases the height above the surface. Speed is already there because energy is there, but height also get increased above the surface. Surface is here. This is a low water mark. Okay, so this is actually high water mark. This is a low water mark. So low water is here, high water. This is the usual movement of the waves during the low tide, high tide on the beaches. it will move only within this one. However, if there is a cyclonic wave or if it is tsunami wave, then particular tsunami wave, then because of the energy, it get intensified and this water will be thrown away above. So above it can be like tsunami, it was 100 feet, like this, almost 30 meters. So 100 feet with the speed of a jet, like 5 to 1,000 kilometers per hour, it is coming. So it will come and take away whatever is available here. Nothing will be spared by this one. That is what it is, the most disastrous occurred. Now these are the countries which will get affected. Like for example, these are, it is shown it during that time, how many peoples were, death, and how many peoples were missing during just next few days. This is what the scenario was there. Those 14 countries, India, that reported. It was much more than this actually. This was immediately, because this was the figure available next day, and that is how it was there. So Bangladesh, Myanmar, India, then Arabian Sea, Maldives is, Sri Lanka, it is here, Andaman Nicobar, most of the Andaman Nicobar island was completely disturbed, and some of the areas were totally destroyed. I'll show you some of those evidences also. Then Malaysia, Indonesia, then you have Thailand, the huge impact was there, Myanmar, Bangladesh, and down also. There were some islands which were, highly impacted. So here was the epicenter. The cyclonic epicenter was here of Sumatra. This is Sumatra island was there, and this is of Sumatra, it is there. Well, this is not the only, that was in 2004, but recently also in 2020 also, there was a major tsunami occurred, and that tsunami was near Australia, New Zealand. There is a small island called Tonga. The Tonga island is somewhere here, and that Tonga is a country. So there are different islands there. Many islands are there. So one of the island, this volcanic eruption occurred here. This is the actual photograph of that island, and this is the eruption which is occurred here. So this was happened in island. These are another islands are there. So here is the place exactly what it happened on 15th of January 2022. And this is the island. Again, what we have aerial photograph of that island when the eruption occurred. So this is a small island, and this eruption occurred here. And this is the actual photograph of that eruption. When it came out, the lava is with smoke and all this, undersea volcano. It was undersea. Nobody was knowing that there is a volcano there. Island was there, but then it was a small island. But there is undersea volcano got erupted in the Pacific, this Tonga Island, and it generated the tsunami. So the volcanic eruption was very large. This was the third largest eruption recorded in the history, and particularly that year. A huge 20-kilometer have mushroom type of smoke. So this is the mushroom type of smoke. You can see that it was a height up to 20 kilometers. Loud smoke and ash was followed by the tsunami, and the eruption was heard in the Australia and New Zealand. You can imagine Australia and New Zealand people were able to hear that the eruption of that earthquake. So this is what a recent 2022 earthquake and subsequent tsunami, the damage caused by this Tonga was also very high. Particularly almost like 1 lakh people were get affected in that area. 80% of the population of that island, which is around 84,000. So 80% of the population got affected, and you can see how it is, after that eruption, what happened. Everything, small island, everything got completely altered. The disaster is so that the people are not came back to their normal life even today after 2-3 years. That is what have been reported. So undersea volcano eruption which happened in Tonga on 15th of January 2022, it also sent the waves of tsunami. So this tsunami came across not only that particular island, crashing across the shores and pushing all the people, even whoever they were in the lowland area, they were trying to escape because it was an island. There is no much escape is available. It's a low-lying area island. There are no mountains and this type of things available, except few of those. So people, whoever it was possible for them, they were rushing to the higher areas. Same thing happened, in fact, in the Andaman when it occurred. So this is what aftermath it is there. So after the Tonga eruption occurred, what happens there? You can see it. This is the structure now. It is visible now. So this eruption have converted into the volcanic lake. Now it is there. It is visible. It has got the width of around 2 kilometers, roughly. Okay, 4 kilometers, not 2 kilometers. So this is the diameter is roughly like 4 kilometers. It is there, and depth is roughly they say it around 2 kilometer depth is there of this one. And this is the height. What is there? This is water. Blue is the water here, and this is above the water. It is a new volcanic eruption, and crater is generated. So this crater is like what we have crater in what is called in Maharashtra we have Lonar crater. But Lonar crater is created by the meteoroid, whereas this crater is a new one. It created with the volcanic eruption. We do have it such volcanic eruption crater, and every roughly 10 to 20 years it get live volcanic eruption in the Andaman, and it is called the barren island. Barren island means nobody is staying on that island. It is within the Indian territory, and that volcano also get erupt sometimes. But this is the undersea volcano, whereas Andaman one is on the land. It is there. The crater is already there. The mountains are already there. Now here, because of this eruption, the new mountain range is occurred. These are all red is the land now. So red is the land now, and this is shallow. This is a peak. So mountain range occurred due to this eruption. So new crater hole created in Tonga volcano, which is a huge one. As I was telling you, is a 4 kilometer wide it is, and that is why this complete water, whatever was here, have been dispersed with that speed. And therefore, you can see that it is around 1 kilometer height now from water. This is 850 meter. You can see this. And this 30 meter above. Okay. So this is 30 meter above. And this is how it is. The crater is around 1 kilometer depth, and height is above ground is around 30 meters. So mountain is got it. New mountain range. Same thing has happened also in some of the places. You can see that those islands, which was earlier one island, something like this. And this is the place where the eruption occurred. This was the height where this Tonga eruption produced the biggest atmospheric explosion recording on the earth, in last 1 century. So that is how it, was possible to people to listen in your New Zealand and Australia. That is why it was biggest explosion it recorded on, on the earth till date. And that is that also because the pressure was so high, the eruption was so much intense, it created the tsunami. You can see that the island, which was, one island before the eruption, this is how it was there. After the eruption, you can see it was divided into many different parts like this. It was spread like glass piece. If it falls on the land, surface, how it will break into the different pieces. This is how it was broken, and new different islands are formed. Now you can see that these are the different small islands. Here is there. All that is broken and converted into the different islands. This is how the tsunami after that. The tsunami occurred, and you can see the cities, whatever was there in that area, are submerged into the water everywhere, because whatever the buildings are there, some of the building got damaged, most of them, and water also inundated into the tsunami. So, what have we learned from this? I think so. If you agree, we'll just have a break, tea break, and come back after 15-20 minutes, so that I also will have my tea. You can also. Is it okay, Chavan sir? Or if anybody is there from HRD? Hello?
Okay, sir.
Okay, na?
Yes, yes.
So we'll come after 15 minutes?
No, sir. Only 10 minutes.
Okay. Okay. Hello, good afternoon. Is there anybody available from HRD? Should we start? You could see some movement of Dr. Gonte. Should I start, sir? Okay, I got the green signal now from HRD also. So now what I was talking to you that the 2004 tsunami and also the cyclones occurring earlier than that, there were a lot of disaster happened, particularly with respect to human beings, loss of the human life and the coastal property. The one of the major reason was there was no tsunami or cyclone warning center or system available in the Indian Ocean region, entire Indian Ocean region during that time. Although cyclone up to certain extent was being taken by meteorology, and with whatever the modeling they had it based on, they were able to give some information, but not that accurate, and that early warning was missing. So what we have learned it from this 2004 tsunami and with respect to the coastal disasters, we'll discuss a little bit about that now. So, scientists have, a lot of discussions were there earlier based on the, particularly on the 2004 tsunamis. There were globally also huge debates were going on that what caused such a big tsunami, and then after the waves which triggered powerful tsunami, same thing like volcanic blast which travel into the atmosphere of Tonga, and which erupted the volcanic eruption and then subsequent tsunami. The waves cover with each of these, and the energy continuously pump into the tsunami, which which was growing bigger and traveled much further than and within limited time. So the eruption of Tonga volcano on 15 January was the largest volcanic eruption of the 21st century and the largest eruption since Krakatoa eruption in 1883. It has been described as the biggest explosion ever recorded in the atmosphere and was hundreds of times more powerful than the Hiroshima atom bomb. You can imagine this. This is important because the eruption which occurred in the year was the biggest natural eruption occurred in the recorded history or in 100, and its intensity was very high. It was such a bigger, it was comparably much bigger than the atomic explosion which was dropped by America on the Japanese city called Hiroshima and Nagasaki. So that is the one thing. And the disaster, what happened also was very important of the tsunami which occurred in Japan in 2011. Okay, the major tsunami was 2004, but also in March 2011, there was another earthquake which triggered around the magnitude of 9 near the Tokyo. It is Tohoku, called as Tohoku earthquake, and it created havoc into the city. That was on 11th of March 2011. The disaster began when the magnitude of earthquake of 9 shocked the region in the early afternoon, and then it got converted into the tsunami. But most important thing during that time was there, it happened in the city where there was the nuclear plant available. A Japanese major nuclear plant was available there. And you can see how the tsunami has come to the road. This is the road, cars were, this is a road, and you can see here is the coastal highway. And so all the water rushed towards the road, and then it was flowing on the road. You can see the height of the waves, how it is there. The post-tsunami, because it roughly around more than 15,000 people died. Tsunami also damaged the entire infrastructure in that city. You can see all the buildings, the roads, everything, electrical supply, all the essential supply in that area was completely damaged. Okay, thousands of homes, business, roads, railways. The tsunami, most important is the disaster caused into the nuclear reactor, which was in the Fukushima near Tokyo. That is called as Fukushima Daiichi nuclear plant. And I was in Japan early in 30 years back. Actually, I had been to the Fukushima, Tokyo, Hiroshima, Nagasaki, and also Osaka. So I have seen those areas, particularly Nagasaki and Hiroshima, how the disaster of atomic explosion took place in Japan. And this was much bigger than that. That is what Tonga explosion showed it. It was bigger than that. But this tsunami, which occurred in Fukushima in 2011, was dangerous because it hits the nuclear power plant in Fukushima. And this is how it was, the post Fukushima reactor 3 and the because the water, in fact, today they have not officially released much information about the radioactive substances. This is the major disaster. One is the earthquake, post-earthquake is a tsunami, a disaster. But the third most important is post-earthquake is the Fukushima reactor and the nuclear material which got exposed to the air, which got exposed to the water. They have officially really said that we had shut down the reactor much before the water could enter into the systems. But we don't know officially. Not much information have come out from those. So I'm not fully aware about the after effect of tsunami, particularly on the Fukushima reactors and nuclear, leakage or nuclear radioactive material leakage or seeping into the water or in the system. But there are some hearsay reports, news report that there were some radioactive material even noticeable into the fish and other organisms. How much true it is there, officially I'm not aware about it. So I'm not talking much about it, but it was very dangerous, particularly if you look at it, the toxic material. And this is how it was. You can imagine this is the nuclear plant and water is completely filled in that area. So what must have happened in the post? They have, of course, they said that we have shut down this thing, so there was no eruption or no blast occurred. And from that matter, may not have been escape of the radioactive material, but we don't know exactly what happened because they are fully flooded. So this is how, again, that earthquake, which was around 9, the Richter scale 8.4, that's what they say, on the 11th of 2011 it occurred. And we know how much damage it has. Official figures say that Japanese Nuclear Safety Commission was quoted as saying that reactor meltdown remains possible at the Fukushima Daiichi power plant. Thousands of people have been evacuated from area around the two plants. A massive rescue and cleanup efforts is on the way during that time on 11th March, which has been described as the 5th most powerful earthquake to occurred on the earth, in the last 1 century. This is what the official figures they have told about it. And but that's what I say. What happened to radioactive material, elevated radioactive material levels in the water or cooling system or in the organisms? No figures, at least I'm not aware about that. So I don't want to talk much about it. But this is how the water got, because tsunami. You can see that the effect of great earthquake, which was stronger in Japanese recorded history, were felt around the world also up to Norway. Even in Antarctica, the measurements and then effect was visible, which has, up to the North American beaches, the tsunami's effect reached even North American beaches. In Japan, residents were still recovering that as November 2021, till that was, recovering the people. There was about 39,000 people which were homeless. Around 1,000 of them were living in the temporary houses in 2011. So you can see the after effect of the disaster. And this is for the government figures, Japanese government figures, and how much distance they travel. So this is Fukushima city here on the land. It occurred here near the city in the sea. And then you can see how much it is. 3 hours, the impact, 6 hours, 9 hours, 12 hours, 15 hours, and 18 hours. And this is the South America. You can see this is Chile here, and then all different South American. So this is where it took around 20 hours to reach here to Antarctica. Roughly down south is Antarctica. And this is down here is the Antarctic Sea will be there. Then you have Mexico, some of those Mexico and Hawaiian, this thing is there. And this is North America, as you can see, the Canada here. So this is how it is. Australia, is, within 9 hours it reached Australia, and within 6 hours to New Zealand. So other islands, it was quite fast. Like Thailand and those Philippines and those islands, somewhere here they were there. They were also in 3 to 6 hours, it reached there. So both East and West Coast, it was affected during that one. The major disaster, of course, was in Japan and around Taiwan also. It was the Korea got affected of that one. Well, what they estimated was disaster damage around more than 120,000 buildings. Okay, around 2 lakhs or more than 2 lakhs were half destroyed, whereas more than 7 lakh buildings, houses were partly destroyed due to this disaster. So according to government figures, that direct financial damage from the disaster was estimated about 16.9 trillion yens or $200 billion. So that is what was the estimated cost of the disaster. The total economic cost, what they said, estimated by World Bank, was more than $200 billion, making it the costliest natural disaster in the history. Much more than because it was on the effect on the land, and one of the biggest city came into the tsunamis, this thing. And Japanese is a well-developed city. That is why the damage was much more in terms of the economical damage there. Well, Fukushima scientists in Japan were, in fact, also, Japan is well developed for the tsunami warning system. Japanese, I have seen it 30 years back, they had very good warning system. Very good system was in place. However, even the Japanese scientists, such a high techno expertise available with the Japanese scientists, they were in fact caught napping, and they could not, imagine that there will be such a tsunami, and therefore they were not prepared about this thing. So they had predicted earlier that there could be a tsunami or earthquake to the northern part of the island. This is Honshu Island. But they did not even expect that such a large tsunami it will be. The hint of the disaster came from the measurement. There was the flooding close to the, but that again was not known. Only they say that there earlier in 169 AD, there was a tsunami in that area, not otherwise. And therefore, there was no history also to occurring such a tsunami or disaster in the place like Japan, where the system, as I told you, that tsunami warning system was placed there. They used to inform about earthquake much in advance throughout the city. I have witnessed that one. But the Japanese geologists are even not aware about this tsunami, because their warning went officially were responsible for the country's earthquake hazard assessment, where they were not able to predict it previously. Okay, so tsunami experts from around the world have been asked to assess the history of past tsunami in Japan and to better predict. So that is how it was done during that time. so that the better prediction. So what I was telling, country like Japan, even in 2011, what happened in 2004 was the Sumatra or Indian Ocean tsunami. But even 2011, when it happens to Japan, which is one of the most developed nation with the scientifically also, technologically, they were even were unable to predict it. Okay. And this is what is the damage which caused during that time to the Japanese, the islands, around the islands. You can see. Okay. What I want to come to the 2004 tsunamis, what happened to the Andamans. Andaman is one of the area which is north of the Sumatra, and it was the one which was hit very badly, where we have studied ourselves into the Andaman. I have visited some of this area prior to the earthquake, much earlier for some other scientific expeditions. But then this was the post this thing, tsunami, and you can see that this is one of the Car Nicobar area, and south of main island, that is Port Blair, and here is the area which is shown in the map, is rich in the coral reef. This was the area which is this is sandy beach, as you can see that around here, and here is the shallow bank is there. This is full of corals. This area is full of corals. Okay. This was before the disaster and tsunami, and this is the post. So what happened? This particular portion is completely broken into the pieces. You can see that this is broken into the pieces, and not only broken, but one part, this part, because Japanese, Andaman Car Nicobar Island was tilted. It was upside down, it happened. One side went down, one side came up. And this particular area with corals, it went up. So you can see that this is how it was before and after. Here is shown it. This was before, and some of the area coral reefs are completely got exposed. But this is not the only. You can see that this is what happens. These are the corals. Water is to be somewhere here. That is why coral could survive there. Big corals, few huge corals. They were able to survive because it was covered with water. So water was here. But because it got tilted one side, so one side went in the water, another side went up. At whichever came up, the corals were there in that, and the corals were completely exposed and they were dead because there was no water. Coral required water, then only they will survive. And this is what it is there. So what happened is, this was the 2004 tsunami. But there are effects, after effect. And these are all areas which is prone to the earthquake. So these all are the fractures. All this you can see this triangle mark are the fractures. So it is possible that such occurrence of this thing could happen any time. It is not, only limited to this. And I was telling you about the Baban Island. We have one Baban Island here. It is somewhere here in the Andaman Basin. It is there. Okay, within the EEZ of where there is a live volcano which erupts once in a while in 10-20 years, which is a live volcano island is there. This is how the satellite picture of the Trinket Island. Trinket Island, also Car Nicobar, down the area it is there. And you can see the satellite picture taken before the earthquake or before the tsunami. And after the tsunami, you can see this island. One island, it is broken into the different islands, and there are different islands have been formed. The mangrove area was there completely, it got destroyed. Some of the area got submerged, some of the area got exposed, and these are some of the new island formed because of this thing. So this is a post-event, this pre-event is shown it here. Well, you can see it another island. This is a close view of the Camarto Island. This is the island which is complete. You can see it here. And this was the one which got tilted. Okay. So this area is completely broken. You can see it, what was available there, and post event, it got completely submerged. Some of the area, some of the disappeared. Some of the area have been completely disappeared. So this is 26th December and this is 21st December. And tsunami occurred or earthquake occurred on 24th night. 24th night December, this happened, and just next day the satellite picture was taken. Therefore, we were having the evidences. It was possible to show it. There were a very important component. I wanted to share it with you in couple of these slides is the coastal structures. Some of the areas which were saved by coastal vegetations, both in Andaman, also in Indonesia, also in west, east coast of India, both after the tsunami or during the tsunami, as well as before that and after that with the cyclones. And that is nothing but the coastal mangrove, which are economically safe and haven for tropical storms or cyclones. And you can see that this is how the Andaman's thing was happened. The coral reefs was completely exposed, whereas the mangrove systems, which are coastal ecosystem, before the tsunami or the earthquake, it was something like that. And after this, it got submerged. So water came up to here. You can see up to here, it got submerged into the water. But some of the areas which are completely damaged, you can see where there was, not much vegetation. And this is how in some areas like Indonesia, and those areas are completely got damaged into the system. But wherever this happened in the Philippines, Thailand and Philippines, you can see that a lot of vegetation is there. Vegetation is growing around the coast, and the wave came from here. So this wave was partially stopped by the plantation there. So this is how the plantations were there, and you can see that whether it is tsunami wave or it is the cyclonic wave. But it was possible, partly the disaster was because these houses are here and they are, completely coconut plantation, and other plantation is there on the coast. And therefore, it was not much damage compared to the areas which were nothing was available on the bank. This is how coastal vegetations, therefore, are very important natural protector for the storms, cyclones, and the tsunamis. This is how the houses are completely protected, because you can see the vegetation is here. Vegetation is here. Post this side, you have the houses. Here also, you have the houses here, and which are protected. So vegetation is very important for the. Now, this is the another very important component I wanted to share with you. Is this is the Sundarban, and because the people don't have much place for living, they have cut the mangroves and they have made the houses there. So wherever they have done that one, you can see the waves and cyclonic water is completely gushing inside. So it is coming inside, flooding this thing, and therefore this island, which is actually was a mangrove initially, is being sinking now. So mangroves, they have cut it because they wanted the place, they wanted land for their house or building the houses, and therefore it has been destroyed. So if you destroy the mangrove, this is what the fate you will get it. Otherwise, because they don't have place to stay there, they have chosen to. Now, what was the Tsunami's amplification little bit was, calculations were done, and therefore it is shown it here. I don't want to talk too much about that one because I already this thing. But the earthquake in subduction zone generally trigger the large tsunami. That is what happens in 2004 tsunami. And the relationship between the earthquake and magnitude of tsunami is complete, very complicated, because I wanted to share you with some information. As I told you in the beginning, that I was part of one of the Discovery Channel's expedition, which explored the possibility of finding the answer for this relationship, earthquake and tsunami. What is the relationship? So tsunami are rare. All earthquake will not, generate the tsunami. In fact, the history of the tsunamis and earthquake suggests that only 1% of the earthquake triggers the tsunami. So the possibility of earthquake converting into tsunami is very less. Just 1% is there. However, any earthquake, if it occurs around the coast and if the magnitude is higher than 7.5, Richter scale, there is a possibility it can get or it can trigger the tsunami. Smaller earthquakes sometimes may trigger the landslide. Now I'll come to that also, the landslide. That is not because of the earthquake, but because of the landslide. There is a possibility that it could get into the tsunami. Well, this is what I wanted to share with you, that in 2004 January, tsunami occurred December 25th December 2004, and just after the 6 month, okay, sorry, after 2 months, not 6 months, after 2 months, there was a team of the scientists from the world. So, 27 scientists were there. I was one of them selected. I was representing entire Asia, in fact. So they were majority of they were from UK and USA, also from France, Germany, and I was from India. So with 27 scientists of interdisciplinary team from geology, physics, modeling, 3 of us were from biology. So 4 of us were from biology, and we came together to find out what is the major cause of the Sumatra earthquake and tsunami which triggered from that. So this was the question. Global scientists in 2005 were discussing globally that what caused such a huge tsunami when earthquake of that magnitude may trigger the tsunami, but not of this magnitude. Okay, so there were different theories put forward by the different scientists. One of the theories they put forward was that the explosion which occurred of Sumatra, which has, because of the plate tectonic movement and subduction of one plate and another plate pushed up, and then the tsunami occurred. Another theory they put it was not because of the earthquake, but post-earthquake, because the area where this place is there is a sediment of few kilometers. And if eruption occurred, the sediment must have been collapsed and it has triggered the tsunami. So there were 2 theories. Both were arguing in globally that this must have been there. To test whether what exactly happened, the global, as I told you, that 27 times scientists came together and we hired an American ship. This was a team which was basically scientists came together. It was not a country, although they were, as I told you, that European, American, and I was only from Asia. Rest of Europe and America only, they were there. So we came together, scientists, and we said that we will go and explore what was the major cause. I was selected basically for that because I have been working in the deep Indian Ocean for last 3-4 decades that time. Now it is almost, 20 years since then. And I was basically deep sea scientist working in that area, in the region. So they selected me in that one. And then we had a problem of funding. For such a huge expedition, we required money. So we said we will not ask government, because if we ask government, then we will be puppet of the government. We want to do the science, so let people come forward. So we put up an advertise in the international journals and international media that time, that we scientists from different nation came together and we want to explore the possibility of finding what is the major cause of the tsunami. Also, we are exploring the possibility of putting up the model which will predict the future tsunamis. So that was the selling point what we were talking, and ultimately Discovery Channel and National Geographic came forward. Both of them, they were ready for funding the expedition, and then we hired the ship, which was very expensive. As I can tell you that in 2005, the ship which we hired of American, this was the on-board photograph. This was the ROV, remotely operated vehicle. This was the main equipment we had on the ship, which we sent down. And there are the cameras, there are robots into this one, which will collect the sample, which will take all the photographs and also measure different type of measurements. I'll show you what type of measurements it will take it. And also the samples it will collect. So that was available on that ship. And then it was very expensive. Like that time, 40 crore per day we were paying for that. But the Discovery Channel gave it all those things, not this thing. So we went with the ship. Initially, the ship wanted to come to Andaman, Port Blair, and they told me to, see if we can get the permission from Indian government. I went to Delhi, all the proposals, scientists came together and we want to do the research. But that time, we need to come to Andamans, Port Blair. So ultimately, we had to go to Indonesia. So Indonesian government also, because it was not very good relations, they did not allow us to go to Java. We wanted to go to Java, and from there we wanted to, take this thing. But then ultimately we went to Bangkok, Thailand. There is another city called Phuket. So Thailand government gave the permission to bring the research ship there, and there we sailed it. We 20 scientists sailed from Phuket, Thailand. It was more than 1 month cruise was there. And then this is the team of scientists, what we did it. It was a CETOS team, what I already explained you about the CETOS is Sumatra Earthquake and Tsunami Offshore Survey. This was called CETOS, Sumatra Earthquake and Tsunami Offshore Survey team. And you can see that this is from the USA. One scientist, our chief scientist, Kate Morgan, she was a lady geologist. David Tapping was from British Geological Survey of India. He was from UK. Then there were, from Canada, USA, Canada. Then there were some from France. There were 2 or 3 from France, Rhode Island again. Then this was a team. This was the geophysics group. Mapping, they were doing it. This is the team which was doing the modeling. This is the team which were preparing the maps, visualization. We have it from Canada and USA, the team was there. This was a team from the biology. So you can see that National Oceanographic Center, UK, there were 3 of them. And then I was from National Institute of Oceanography. This was from the France, one lady. So we 4 were from the biology. And then again, we had 3 fellows which were modeler. This was the Discovery Channel team which were taking all the videos, photographs, all the photography they were doing. So the production team was from the Discovery Channel, entirely from Discovery's people, they were together. So we were on this American ship, this is a ship performer, his name was Performer. And here is, we went there, we collected a lot of material. So goal of the sea floor was to gather the important modeling data from the sea floor displacement, whether there was any disturbance to the sea floor caused by the tsunami or landslide we wanted to study. And for that, we collected different sediment samples. You can see this is myself, this is Paul Taylor, this is from this is from France, this is from UK, this is from UK, this is from UK. So, and then primary objective of our team was to compare the life on the sea floor and to study it whether this sea floor was disturbed by the earthquake or was not disturbed by the, that is one question only we wanted to answer it, whether there was any landslide. Landslide is nothing but what I can tell you, that if as a child we all have done it and we have seen it. If you are going to school as a child, you will see during the monsoon time there is a porthole or a small dam, a lake will be there. So we take a stone and we'll throw into the water body. If we throw it at stone into the water body, it generates the ripples. Those ripples are nothing but the wave and energy you are throwing in the form of a stone. So if you throw the stone, it will generate the waves. Impact of that stone will depend on what type the waves are generated. And that is the simple explanation is there. Suppose if there was a or only it held into the water, that will create the ripples and that will create the waves. There are the scientific evidences earlier that yes, such huge Himalaya type of mountains are there into the sea. Bigger than Himalayas, they are there. And if that collides, if it falls into the sea, it will definitely create the water waves or tsunami. But then if that happens, the sea floor will be disturbed completely. So we wanted to map it. We wanted to survey there that if there was disturbance caused such like that and it was there landslide. So we had the equipment, as you can see that these are some of the robots handling it. They're collecting the sediment, undisturbed samples. We brought those samples up, then separated it. What type of life is there? What type of chemistry is there? What type of geology is there of that area? We surveyed it. Then we mapped it. We sent our unmanned vehicle ROV down with, and this was the area, but there was no map available where it happened. So tsunami occurred exactly here. There was a big hole there. We could see it there. So we went and we put it, our equipment there inside. And this is how the base map was prepared. The ship was moving like this, up and down, up and down, up and down. And then we were moving here and there. And then we prepared the map, bathymetry of the depth and topography of that one, which was not available earlier. And you can see it here. This is the earthquake which occurred here. Okay, so this is our study area. Our ship was here, and then we send a equipment which is submersible. You can see it. It is going with the wire. Ship is here. It went down. Here is the earthquake which happened. So there is a hole there. That's what we call a ditch. So it went inside and then it has mapped. So you can see that this is a freshly collided surface. This is a freshly collided surface of the sea. So land sediment, which is kilometers in depth, was broken and fallen into the sea. So there was a possibility, what was actually speculated by some of the scientists, that there was a landslide. However, was this landslide sufficient to generate the tsunami? Was not known. So what we did, we made a measurements, seismic measurement here, what type of energy is required to break, what type of energy it will disperse it when it actually fall into the water, how much is the crater it created, and all those measurement details we did it. And then we, did complete study of the geology of that area. And then the fact shows that the cliff is clumped, eroded, covered with the seafloor life. It clearly indicated that it was created recently because of the shift of the sediment or because of the fallen of the seafloor. So this is how it is. You can see that the blocks of sediment, which are fresh blocks, which are fallen like this. And in that we have collected the samples. We did get some of the organisms which are, microscopic one. And those are the recent one. So these some of the organisms, these are the sponges, they are the starfish, and there are small larval forms are there, which fishes feed on these forms. And sediment core, you can see this is sediment core, which is in my hand. We divided into, different sections, small. Then microscope study, we did it. Here is, these all benthic organisms live in the sediment, but they survive because of the particle flux which comes down from the surface. So phytoplankton which falls down after its death, these organisms feed on that one. So they grow here on the sponges, some of them. Also, there are some organisms which were found on the rocky surface there, or hard substrate. There are some fishes, as you can see it. Okay. Then this is how some of the organisms we got it, which live undisturbed area. So that is also important. What is important is here. You can see the measurements taken in the Thailand. Thailand, one of the island where the earthquake of the tsunami occurred, hit, and in that area there is a crack. The visible crack is there. This is a valley, and here are two parts of the crack. This is the one, and this is up, and this was not there before the tsunami. So it broke into two pieces and it went up and down. So here the measurement, even after 4 months, it has not gone down. So here the scientist, you can see his height is around 6 feet. So it is up to here. He's standing on one piece and another piece is up to here. So around 5 feet, 3 feet. Here is the, subduction of this plate is around 6 feet. It was measured during that time. Okay, what happened during the earthquake was much more than this. And water above this plate was moved 100 feet. This is what happens because the people were not prepared for this tsunami. Now, what is the lesson learned? I was telling you that one question was there, that when the next tsunami will come and where it will hit. And as I was telling, there are a lot of areas like Fukushima's, here is a nuclear reactor is there, and there are other parts, you can see that. And if this is the valley, we have the areas in the Arabian Sea also, something like this. And if the tsunami occurred, what will happen to such cities? So can we, prepare ourselves or better prepared for such disaster? And what are the possibilities of preparing ourselves or be ready for? Because nobody can stop that. Tsunami, nobody can stop. What we can avoid is the impact of that on the human being or the property or the coastal ecology. If we can get the information much in advance and then give those information to the people living in that area, evacuate the people, then also at the safety level, if there are nuclear plant or something, we can shut down in the, much in advance. Also, the nuclear, particularly if the radioactive material is there, which can be shifted away from the such impact area. So those things is possible if we can do it. So the study what we conducted was very helpful. For example, to setting up the tsunami warning system. And subsequently, Government of India now came up with the tsunami warning system, which is in place in India, we have the center, Tsunami Warning Center, which is Incoe's National Remote Sensing Institute in Hyderabad. So they continuously collect the data. And how do they collect the data? We have the underwater and on the coast, those recording systems are there, which records the movement of the plate at the earth. So here is, for example, a detector. Detector is there. Then we have the hydrophones deployed to the data buoys. There is a data buoys floating in the sea. There are hundreds of these data buoys. We have put it across the Indian Ocean, both along east and west coast of India. They continuously record, it is anchor and acoustic movement. So hydrophones record it, the movement of the earth here, this is, and then it will send the intensity of that movement through hydrophone to the recorder. It will transmit the data. Here is we have the float. It will transmit the data through the satellite, and through satellite telemetry, it will go to the Incoe's Hyderabad. So here the Incoe's will analyze the data, will process all the data, and this data will be then, after processing, it will be immediately, if there is any sort of warning to be issued, it will be immediately issued, maybe sometime 2 or 3 days in advance. Here you can see that. So acoustic is put it down, it collect the information, send it to satellite. See, the wave is moving. So you can see underwater sensors are there. It will record the wave movement as well as earth movement, and then send to the satellite. Through satellite, it will be near shore, and then it will go to Incoe Center Station, where it will be analyzed and processed, and then give the information through Doordarshan or radios. Alert system will be passed it on to the different media. And this is how it works now. Continuously, people are monitoring it. Continuously, we are collecting the data, and that is being analyzed. So it is system of tsunami warning as well as disaster warning system, particularly like cyclone or tsunami warning system, is available with Indian Meteorology Department, and the Incoes together are processing this data, collecting this data, and making it available for all the. So also we have got placed the tide gauge. This is what I was just telling. These are the areas where we have all along the coast, from Paradip, even in Sundarban, to all harbors, major harbor. You have Paradip, Visakhapatnam, Chennai, Tuticorin, Colombo, then Kutch, Kochi, then Marmgoa, Okha. So these are the Indian coastal harbors. All these harbors, we have put the tsunami warning system, particularly data collection system are there, which we call the data gauze. So it measures the height of the waves, also other parameters like temperature and other also they. So the data gauze are put and along the entire Indian coast, from Paradip to the south, Chennai, and also, as I told you, up to Okha. The sea level oscillation, that is what the movement of sea level and the waves is measured continuously, and then that will be sent to the Incoe Center for the processing, and then that is how we process the data, and then it will generate the movement if it is going in any sort of. So what is important is how important for the city like Mumbai is Mumbai prepared for this, because what they do it usually for city like Mumbai, because they are putting it all the concrete structures even along the beaches also to protect it. Whether that will really protect the tsunami waves or not, very much impossible. And this is how it is there. Big cities near coast, we have, out of the 4 metros in India, we have 3 metros like Mumbai, Kolkata, and Chennai. Except Delhi, all 3 are along the coast. Major population is living there. Major business of India is going on in these major 3 cities. Therefore, how are our cities protected? How much they are protected? If you look at it, not much it is there. There is already sea wall. I was telling you this is Mumbai, and we are constructing like this sea walls. All concrete material is put it here, and behind that we're building. We are such building. Marine line is the best example. Both in Chennai there is a marine drive, and in Mumbai also there is marine drive, and they have reclaimed the areas completely and put it this type of concrete structures along the coast. That is not going to be very much protective for this. What we need to put it probably wherever it is possible. Wherever it is possible, not all along, but wherever it is possible, we probably need to come out with some sort of a solution, is a natural solution. A natural solution is also possible because it can mitigate the temperature. So if you can put the plantation, mangrove plantation, wherever it is possible, wherever muddy areas are there, if you can put it, you can see is a highway, it is built up here. Both the side is the mangrove is there, and here is the sea. The complete sea is there. So if it is possible, why not go for such type of, natural based solution? It is possible to do it. It's not that it is impossible to do it, but then we have to think, whether we can really go for such solution or not. I think so with all of you. Thank you for your time, valuable time, and thank you the Dr. Babasaheb Ambedkar Marathwada University Malviya Mission Project or Center, Training Center for inviting me, Dr. Chauhan, Ramaraoji Chauhan. Special thanks to you and your team for inviting me and allowing me to share my experience and little bit knowledge, whatever I have gained over last 40 years with the teachers, lecturers around the India, so that they could disperse the knowledge to their students and wherever it is possible. So thank you very much, all of you. I am available now for another 15-20 minutes or whatever is the time is required for the interaction. I request HRD team to please unmute the mics of the participants so that we can have exchange one by one. You can raise your hand. Somebody will be there to monitor it, and then we can go ahead with questions if you have anything. Thank you once again. Sir, I have finished now. Can you unmute these people so that we can have the, yeah, please, yeah. Thank you. You can put your question in the chat box. I can even reply if the question is, suppose if somebody is not there to unmute, doesn't matter. Participants, I request you to put your question, if anything is there, in the chat box. I can, revert back to you.
ऑल पार्टिसिपेंट आपको अनम्यूट किया है।
Hello, sir.
Hello, sir.
Hello.
Hello.
Hello, sir.
Sir, I am roll number 56 myself. I am Dr. Shahida 80. Sir, actually, I was hearing your presentation like a cinema or a storytelling. It was really interesting. I am from Max background, and I have many things came to know from this presentation. So, like the volcano eruptions and the other thing, shall we get any clue or any information related to this kind of mass disaster like a tsunami before it happened? For the not for the ordinary people, for the peoples like you, like expert in this area. Sir, you are muted, sir. I can't hear you.
Yeah. Yes, ma'am. Actually, yes, it is possible. And that is why on that basis, only the tsunami warning center is best. Tsunami warning center is best because from mathematics background, so you can understand it very well. There are acoustic recorders which records the waves as well as the earth movement. And there are the hydrophones kept to transmit those information through satellite. And it is a continuous recording is useful. So through satellite, satellite telemetry is used, which is continuously passing that information to the inquiries in Hyderabad, where you have the data processing unit is there and the process is continuously. And such a movement which there is any change in the regular frequency, they will monitor it for hours together and they will see if the increase or decrease of the frequency is there. Based on which area the signal is coming, they can see that which area the signal is coming and what is the intensity of this. So they have the models there. They can put in the information in model and then model will tell it that in this area, there is a possibility of earthquake. Once they get in possibility of earthquake, intensity of earthquake also is calculated and then depending on that, it is, send the information for the tsunami. Whereas as far as the cyclone is concerned, we have very good system already available for cyclone prediction center. It is because with the wind and flow of the wind direction, you can easily generate the image of the satellite, the wind cyclone movement. And then you can, based on the calculations, you can again also calculate where is going to the landfall, what time it will be there, which area it will be there. So then in that area, people can be evacuated much in advance and we can save the life of the people in advance. So the system is very much available at present. So tsunami prediction is possible. Somebody was asking whether tsunami prediction is, that is what I have been telling. Yes, it is possible now.
Yes, sir, thank you. So
Hello,
it will
sir.
help to save our people.
Thank you. Yeah, exactly.
Hello,
Thank
sir.
Yeah.
Myself, roll number 19. First of all, thank you for giving us valuable information about the cyclone.
Sir, can you identify yourself? Roll number is fine.
Myself, roll number 19, sir.
But your name, if you can tell, it will be good for everybody.
Organization has not told us to give the names. We are recognized with the roll number.
Tell us, no problem, no problem. Yeah.
Simple question is that how much threats to all global lives, including nature and mankind, about the global warming and arising of the cyclone and tsunami?
Sir, it is very much, we are very much threatened from global warming. One is
Yeah.
temperature is increasing every year. Whatever temperature was last year, if you see this year, it is going to be increased by some, few points. And if that is happening in long run, it is already showed last 50 year 1 degree is increase. So if 1 degree for the sea surface, 1 degree increase means there will be more salt formation. There will be more evaporation. And if that is evaporation, is more, there are more clouds formation. So there will be more rainfall. Somewhere there will be more drought. And if there is a more rainfall, we know what is going to happen. But if it is more, temperature, it will also get evaporation. It will generate the wind. That wind will also get converted into cyclone, and that is how we are getting cyclone frequency more and more. So it is going to happen. It is not a theory, it is a practically happening. So global warming is a reality. We have seen it, we are measuring it. So there is no doubt about it. Somebody has asked me a question about Lonar Sarovar, when it was. I don't have the exact age of it, but I think so it is already available somewhere in the books or somewhere. Right now I don't have exact figure to tell you, but I read somewhere there is some information on that. Anybody else? Anything? Oh, somebody has also asked, are satellite image useful for tsunami? Satellite image may not be useful for tsunami prediction, but images are definitely useful for calculating the disaster, how much damage has been done. Because usually satellite images are taken post. If we have pre-images, then we can compare with pre and post.
I have a question.
But, yes, madam.
Sir, please let me know about the radar system and early warning system in regarding the disaster management.
Madam, mostly the radar systems are placed there are meteorology centers are there all along the coast. Their major radar systems are placed there, and those radar systems are very effective. They are getting all the information related to wind and temperature, measuring it. We have the modeling station in Delhi, major modeling station in IMD Delhi. There the data is collected and they are modeled there, and now it is also placed in Pune. So Pune center will analyze the data along with the Delhi center, and then they will process for the early warning of the cyclone or the storm. That is how it is working. Somebody has asked whether we have future chance of tsunami. This is an interesting question, but I don't have answer. Can't be ruled out because earthquakes can be measured not in that much advance, but movement, plate tectonics movement does indicate which is the weaker section of the plate or ridges, and therefore the possibility of which area is more prone for the earthquake can be mapped. Andaman is one of such area in our Indian subcontinent, which is very, prone to the earthquakes. Also, as we know, Nepal is the extension, Nepal and India, that is the north extension of the same plate. If you go to the west coast, Pakistan, Iran, that area is again Afghanistan, Pakistan, Iran, another ridge passes through that one, and therefore those are some of the area where frequent earthquakes are being recorded. But whether that will get converted into tsunami cannot be told right now, because maybe in few days in advance they can predict it. That is why it is possible. Thank you.
Shall I ask a question, sir? Hello?
Yes, please go ahead.
So you just told that nowadays tsunami prediction is possible. But my question is that is there any instance that any country which recently used the tsunami prediction that is their part of their mitigation strategy for
Yes,
tsunami?
yes, very much there. Even in India, we had given the warning 1 or 2 years back. Warning was, based on the calculation, but it doesn't, get converted. That's what is the chances. If you have seen my presentation, I said earthquake getting converted into tsunami is 1%. So these are predictions. Well, in advance, the informations are given. Not necessary that it will get converted into the tsunami.
Yes, okay.
Important is we giving the information. We are able to give the information to the people much in advance. Evacuation, whether to do it now, they will tell in few hours in advance. But preparation for that evacuation is very much has to be done in 1 or 2 days in advance. And for that, warning is very useful.
Okay, sir. Thank you.
So yes, it is being used.
So one more question.
Sir,
One more question. Hello, sir. Can you hear me?
Yes, yes, ma'am.
So one more question I would like to ask here. So as we
Yeah.
know that technology has gone very far.
The same is
So
Hari.
instead of going for the impact of this tsunami, whether we should have some preventive measures, what is the root cause of this tsunami, and whether we can stop this.
Madam.
Yes, sir. Myself, sir. Let me tell you.
Yeah.
Myself,
I
myself.
understand your question, but root cause of the tsunami is earthquake.
Yes,
and
sir.
which cannot be stopped by anybody because it is happening in the core of the earth, 30-40 kilometer down.
Yes, sir.
The movement can be measured. We can't stop it any movement. Measurement can be done, but we can't. That is why movement based the prediction system is there. That also chances are only 1%. Important is we can save the life.
Okay, sir. Thank you, sir.
Okay.
Okay, we'll go for a vote of thanks.
Okay, sir.
Roll number 12.
Thank you, sir. Good evening to all of you. It's a great opportunity for me to give in this opportunity to vote of thanks. First of all, on behalf of Dr. Baba Sahib Ambedkar Marathwada University, Chhatrapati Sambhaji Nagar, and UGC-MMTTC Teachers Training Center, thanks to our today's resource person, Baban Ingole Sahibji, simultaneously has delivered 2 lectures. The first lecture was impact of cyclone on coastal environment, and second lecture was impact of tourism on coastal environment. Very interesting and informative lecture, and sir delivered simultaneously 2 lectures from 3:30 to almost now 6 o'clock. First of all, I try to highlight the first lecture, impact of cyclone on coastal environment. Sir, focus on what impact do cyclones have on coastal areas. Tropical cyclones remove forest canopy as well as change the landscape near coastal areas by moving and reshaping sand dunes and causing extensive erosions along the coast. Even well inland heavy rainfall can lead to landslides in mountains areas. And another my observations are focused on what are the environmental impact of cyclone. Tropical cyclones and large storms are natural meteorological events that have significant environmental impact. Such events typically bring high winds and large quantities of rain, which may cause storm, tides, coastal erosion, flooding, landslides, vegetation, die-off, and other impacts. My another observation regarding the first topic, why are the cyclones bad for coastal community? Of these, storm surge cause the most damage as seawater inundates low-lying areas of coastal regions and causes heavy floods, erodes beaches and embankment, destroys vegetation, and reduces soil fertility. And my last observation regarding the first topic, what is the conclusions of the cyclone? Cyclones are natural calamities that strike as violent storms and grievous weather conditions caused by disturbances in the atmosphere. They lead to great devastation. The effect of a cyclone is terrible as it destroys everything in its way. The second lecture, Baban Ingole Saidji delivered, Impact of Tourism on Coastal Environment, is very interesting and informative lecture. I have never seen such like a speech or lecture. What was the impact of the tsunami on coastal areas? Tsunami waves can produce extensive changes in coastal line topography due to considerable erosion and subsequent depositions of substantial quantity of sediments in relatively short time span. My another observations, how do tsunamis impact the environment? The force of the water, pollutant and toxic substances, sediment, marine debris, and invasive species can also harm agricultural land and natural resources. On shore and off, changes of those resources can affect the services they provide. Examples such like the biological, ecological, protective, and recreational. These are my observations, and on behalf of Baba Sahib Ambedkar Marathwada University, lots of thanks, and on behalf of all the participants, thanks to Professor Dr. Baban Ingole Saidji for his nice, informative, and interesting 2 consecutive deliberations. We have lots of know the new things, new ideas, and very informative. And on behalf of myself, again, thanks to Professor Ingole Saidji. Thank you, sir.
Thank you, sir. Thank you very much. Once again, I would like to thanks the HRD, Baba Sahib Ambedkar Marathwada University HRD team, HOD, and Dr. Chauhan and his team. Thank you very much, sir, for inviting me.
Thank you, sir. Thank you very much.
Thank you, sir. Thank you.
Thank you.
sir.
Thank you, 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 sir.
Thank you,
Thank you so much, sir.
Thank you. Goodbye.